I'm Kaushik Tripathi, your instructor, and today we are going to talk about blurring or smoothening of images. Okay, so blurring concept is basically if you've seen in your phone the bokeh effect or no this effect only, where you see you blurred out certain sections of the behind and you focus on some image, something that you want to put a focus on, and you blur out rest of the things. So today, we are going to learn how our image processing, how these image processing tools will help us automatically blur out certain sections of the image or the total image, and how they are gonna blur it. There are lots of methods. We will work out all the methods. We understand where which kind of method is used, and this is all. Let's see it in a Spider ID. All about these methods. Okay, so here we are. This is our program. Okay, there are lots of things that you have already studied, like CV to import, NumPy, MP. This time I have read this apple.jpg file. I will show you what that file is later on. Then I have created this. You can see here I have created two arrays, matrix of 5 by 5. You can see here, and I have named them kernel 5 by 5 and kernel 15x50. And these are two matches. Okay, let me rename it. 9 by 9 matrix. Okay, this is a 9 by 9 matrix. As you can see, np.ones 9 comma 9 means there is a matrix of n by 9 by 9 size with all the values 1. Okay, and I have divided by d1. That's different thing. Then I have, you can see here, I have used few methods. We will talk about them later. And then I have shown all those images. I have just comment out certain, which I will remove the comments later on. And then there's wait key and destroy all vectors. So basically, if you see all these methods, filter 2D, blur, Gaussian blur, median blur, bilateral filter. Sometimes this blur is also called averaging. So these are all methods of blurring an image or smoothing an image. So what happens is basically this is a filter 2D method. So what happens is this filter 2D method works with the help of kernel. Now kernel is like, if you know, image is a matrix. It is a form of a matrix. If you see here, my variable section. Okay, there. I'm just running this program. Don't bother about it. Okay, I'm just fetching out the variables. Okay. Okay, I will CV2. Okay, so if you see here, this is our image 1, and if I open this image, now you see this is a form of a matrix. Okay, and if I see it like this, so this is our matrix of 512 by 512. Okay, I make it full screen. You can see this is our matrix, complete matrix of 512 by 512. Okay, you can see here it says 511 and starts from 0. So there are 512 rows, 512 columns. So now what our kernel does, let me show you my kernel also, what kernel is really. This is suppose this is a kernel of 5 by 5. If I open this kernel, so you see here it has got 5 rows and 5 columns. What it does, it puts on to each of our this matrix, like right now it will put over this part and it will process it the way we are asking it to process. Like we are using a filter 2D method. That means it is gonna, what it does is let me just that. Oh, yeah. So what will happen is, like, this is a 0 comma 0 point, so it is going to multiply with this 0 comma 0 point, and whatever the value will come, it will put that value into that pixel. Same thing will happen with 0 comma 1. It will multiply it with this 0.04 will multiply with 82, and whatever value will come will be put over there. So this is how this filter 2D blurring happens, and this is how our kernel works. So what happens when it will cover this 5 by 5 section, it will move down then again down, down. It will keep on doing up to when it will reach up to the 512th row, then 511th row, sorry, and then again it will move from this much part to, like, starts from 1 to end to 5, then starts from 2 and end at 6, and it keeps on putting its that kernel, which we call a special matrix, which you are placing over the image matrix for evaluating. So what it will do, it will keep on putting itself onto that original matrix and keep on multiplying the values, and whatever the value will come, it will put it into this pixel section. So this is our kernel, this is our original matrix. I think got a pretty good idea what these are. So this filter 2D works in this way. It's like whatever the kernel will provide it, that values of the kernel will keep on multiplying inside of the whatever the values present inside the matrix. Now that kernel, we create this kernel like this by creating a matrix of 5 by 5 or 9 by 9 or 7 by 7 or 6 by 6, whatever your choice, and then we divide it by the multiplication of 5 into 5 or 9 into 9 or whatever the values are present over there. We divide that matrix with a multiplication of the length into breadth. Okay, so we have created, I have created this kernel. I have created two kernels here, kernel 5 by 5 and kernel 9 by 9, two size kernel. You can create any size kernel, 11 by 11, 15 by 50 or 100 by 100 if you want. But remember one thing, the bigger your kernel is, the more blurry your image will become. Okay, I will show you like now. Okay, don't bother about this section of the code. Okay, it will not work because I am not showing anything related with it. I am just running these two kernels. One is like 5 by 5 and another is my 9 by 9 kernel. Okay, I'm gonna run this much of the code and let's see. This is my original image of an apple, as you can see here. Now I'm gonna reveal filter 2D. Okay, this is my somewhat blurred image, but you see it is maintaining the borders but blurring out this section also, and then there is my filter 2D more blurred image, of kernel 9 by 9. Now you see this image looks a lot blurry. This was somewhat good image. Okay, this is our original. Sorry, this is, wait a minute. Yeah, this is our original image, first one, our original image. Okay, it was looking some nice image, original. Then filter 2D image. What filter 2D does, it manages the border somewhat, not completely, and kind of blurring the other things inside of the image. And if you see here, this section, this white section, somewhat yellowish section, it looks a lot more clear and accurate. But here if you see, it is all a little bit of blurred out. Okay, and it also is removing the useless noise from the image that is present in there. It is blurring them out. Basically, blurring is mostly used for removing the extra things or the noise. Like you take an image, you use it in a bokeh mode. So what it does, whatever the background there is, you just blur out the background because that's all noise for you. Okay, you want to focus on certain person whose photo you are taking or certain thing that photo you are taking, and you are blurring out other things because those are all for you. Those are all noise. So that's the meaning of a noise in images. And then there's this third image we have, and it is, you see, it's a lot blurred out. There's nothing, means if you see this yellow section, it is like almost blurred out. It feels like you need a good spectacles to look at this image. Okay, and this outer section also, you see it is blurring out these parts. But what happening is you are not getting a good focus on anything. Okay, it is blurring out the apple also, outer sections also, everything is getting blurred out. No focus is there. So this is filter 2D, and that's how it works. Okay, so now I will comment out this filter 2D cvt.show. Otherwise there will be lots of images in the program in our screen. Now next comes the cv2.blur. This cv2.blur. Now cv2.blur, it also creates a kernel, same type, But in the earlier we have to define our kernels, we have to create our own matrix of kernels. In this we don't have to create our matrix of kernels, it will automatically create your matrix of kernel. What it does is, what are the kernel you have created, like you have created a 5 by 5 kernel, so it will be also values of 1 and 1 1 1 1 1 values, and which will be divided by 1 by 25, as it is 5 into 5 35. And what it does, it will also be put into the matrix, and 5 by 5 blocks. And what it will do is, over there it will take the average of all the pixels values that are coming inside of that block, and take out this average, and will put that average into the, whatever the value will come out of that average, it will put it on the center pixel of that area. That's why in this cv2.blur we take odd size of matrix, like 5 by 5 or 7 by 7 or 9 by 9 or 11 by 11. And that's how this blurring effect works. And if I run this code, okay, let me explain you other, then we will run it all together. These, then the next one is comes as a Gaussian blur. Now Gaussian blur is a blur that use, you know this Gaussian filter, what it does, Gaussian blurring, what it does, it basically, it removes the Gaussian noise, whatever the Gaussian noise that you have inside of an image. Gaussian noise are like, when you take some kind of an image, you take a photo and you find some kind of an illumination problem, like light problem or temperature problem, all these kinds of temperature variation. So it removes all those kinds of noise from that image. Now Gaussian, this, if you see here, we have used this image1 argument, and then we have used this 5 comma 5 argument. This is our kernel size that we are providing it, and we are seeing this, we are using this 0 over here. Now the 0 is all, and this you see here we have created this kind of a matrix over here, which is somewhat incomplete right now. This matrix is how it is formed. There's not just only one matrix that there is that is used in the Gaussian blurring. Then lots of matrix can be used and are created. So how you help out the program to understand which matrix is to be used? We provide these values over here. Like right now I've given it 0 0, and let me show you what values are provided over here. If I basically put here, okay, so you see here it says source size, then kernel size, and then it says sigma x and sigma y over here. Now what these are? Sigma x and sigma y are basically the standard deviations of x direction and y direction. If you have studied in in 12th, 11th, or in engineering, you would have in your graduation, you know what a standard deviation is. So it asks to provide these values, and according to those values, it is gonna create a matrix. So now basically I have not provided any at that time any standard deviations. I've given it 0. When we give it 0, it automatically creates standard what you say, this kernel, default kernel it creates. So I just created a default kernel. I don't want to give provided any value, so I give it 0. So it will accept sigma x and sigma y 0. If you provided any single value like 3, so what it does, it will take 3 as sigma x and 3 as sigma y. It will take 3 as both of the values. So I'm providing it 0, nothing to worry about. Okay, you should work out with all these numbers and find out which is working good in what kind of an image. Okay, these are not just simple standards things like image processing. Every blurring concept, every argument inside of this blurring concept works according to that image. You don't know which concept is gonna work on which image. Okay, every image has its own kind of a blurring. You don't know what every image requires, like in some image you need to blur out something, in some image you need to blur out some other things. So you don't know which method or which argument basically you are going to be using. I'm just telling you how you can use it, so that you can, whenever the things comes, you can change your arguments and keep working on it. So this was about Gaussian blurring. Now there's a one con in the Gaussian blurring that I will tell you later when I will be explaining this bilateral filter. Okay, so I will leave it up to that part. Then we come to this median blur, this part. Now median blur is it is just like a averaging blur, but only the difference is it does not take the average, it takes the median of all the pixels that comes under that kernel of, and we have given it 5 and it takes it as like 5 by 5 matrix. It is it takes a square kernel of same size, so you don't need to bother about that. It is gonna take it as 5 by 5 kernel, and we have given a source image. And what does it? Takes a kernel and finds out all the values that are present inside of that pixel. It takes a median of all that values and put it at the center of that kernel. So that's how this median blurring works. Okay. Then there is this bilateral filter. Now this bilateral filter is like a very effective filter. I mean, I prefer this filter a lot. Okay, it really works out. It gives you edges perfectly. Like, I will not say perfectly, but yeah, it provides us edges like good. And that's the con with the Gaussian filter over here. What Gaussian filter does is Gaussian blur. It it considers the pixels of outside the kernel also. When you put a kernel over that some part of a matrix, it also considers the pixels outside of that kernel, and then it evaluates itself. But in bilateral filter, it also somewhat does the same thing, but it keeps on checking whether that pixel is of edge pixel or not. If it's of an edge pixel, it tries to maintain its um, clarity, I would say. Okay, so when you will see this bilateral filter image, you would find that edges are perfectly shown over there. They are not blurred out like in the other images. Okay, now we see the arguments of this image. So you see this bilateral filter, sorry. So you see I have given it an image 1 argument, then I have given it a value of 9, and then there is this two values 75 and 75. Okay, sorry. So to understand this concept, let's create a, and you see it says source image src, and then it says d, and these are diameter, you can say kernel size, same thing almost, doesn't create much effect. Then there is the sigma color and sigma space. Okay, these things are new that I'm going to explain you right now. So I'm going to put image 1 over here, and then I'm going to give it a diameter of, you can say kernel size like 5, or earlier I've given it 9. Then sigma color. Now sigma color basically says ki, for how much farther difference between the two pixel colors you're gonna work with. Okay, so I've given it 75. That means the difference between the two color pixels, that if their difference is around 75, then they will be get mixed. It will work with those pixels and it will mix them up. And same thing is I've given sigma space also 75. That means for how much farther pixels, means how much, like one pixel is at some coordinate and another pixel is at some other coordinate, so there's a distance between them. So how much farther pixel we are gonna be picking for mixing them up to remove the noise of that image. So that also I've given 75. And this is, so basically bilateral filter is like somewhat kind of a perfect, not perfect, a very good filter, because it detects the edges, it preserves those edges, and it removes it removes noise very clearly, while preserving the edges. So it's like, you got everything in one. So if I just remove these comment sections like blur, then Gaussian, bilateral, and median. Okay, this is all same. Let me move this much also. Okay, so now if I run this image, yeah, I got a lot of images. Now this is the, here this top image, this is the original image. See, it looks completely clear. Then what is the next one? This blur. Now if you see this blur and the original, see it is like, what blur does, it averages out the pixels. Okay, you see it is somewhat got blurred, it is not very much blurred. We have took a very small kernel size, also 5 by 5, but yeah, it looks like you see these outer sections over here, this yellow part somewhat, and here it is like, it looks a lot blurred. we are getting a good focus on this apple over here. But okay, then we close it and we go for this Gaussian blur. And if I put it over here, you see right now we are having a good edges around here, but you see it is blurring out the edges and blurring out everything. Okay, you see inside also. So that's the only con inside of a Gaussian blur. Otherwise, Gaussian blur is a very good blurring effect. It creates a very good blurring effect. But that's the con that it couldn't detect the edges and it does not preserve them. Sometimes it blurs them out also. Like if you see this bilateral over here. Now if you see it is preserving the edges. You can see the edges can be seen clearly other than this Gaussian. Even it is preserving them better than the original. If you see this original, the edges are not that clear, but if you see this bilateral, it has preserved the edges. And you see in these three images, and even if I put this fourth image over here, this median blurring, you see we are getting a good focus on the apple of bilateral than any other blurring effect. We are getting good focus on that apple, and rest of everything is blurred out. It preserves the edges, which is making it look more emphasized on. Now in median blur, I told you it blurs out it creates a median of the pixels, and you see it also did a good blurring, but there is no focus on anything. It's like a very light blurring, If you see here, it is this area is like not clear what is there, but if you see in this, it is like somewhat blurred out. It's like filter to filter you can say blurring that averaging blur. It is like that, somewhat similar to that. Okay, so this is in the blurring. As you see, this bilateral. Bilateral is like a really good blurring effect. Try to work with a bilateral more and more, because you'll find it you are getting good with it, because it really works. Most of the situations, bilateral effect works very perfect, very not perfectly, very good, in a very better way. Okay, so this is the blurring effects. These are all the effects that you can create with these methods inside of the blur. Okay, try to work with these, keep changing the values, work with this bilateral filter and Gaussian blur. You will get a better results with it. Okay, so this is all about blurring. Keep practicing it. See you in the next video.